Okay, so let's continue on chapter 3, section 3. So what we're doing is we're looking at functions, and we're looking for places where the function changes from increasing to decreasing, or from decreasing to increasing. And where you get that change is where you have a zero slope, or where the slope is undefined. So in this case, this is the third order polynomial, and you don't have any cases where this first derivative is undefined, so it's just cases where the first derivative is equal to 0. And then you take those points and you create a table, and you look at values less than this critical number and greater than the critical number, and you look to see whether it's increasing to decreasing or decreasing to increasing to answer the question. And that's called the first derivative test. So let's look. Here's the rule. When a function goes from increasing to decreasing as the x value increases, you have a relative maximum. When a function goes from decreasing to increasing as the x value of x increases, you have a relative minimum. So we'll do another polynomial, and then we'll do a trig function problem. So it says find the critical number. So step 1, find the critical number. So to do that, you take the first derivative of the function using whatever the appropriate rules are. You set the first derivative equal to 0. So whatever result you get from taking the derivative, you set to 0. If you have a common factor, you can factor out. You can do that. Or you could just say I'm going to divide by 3 and reduce down to x squared minus 2. So for this product to be 0, this term in parentheses has to be equal to 0. So we get x squared minus 2 is equal to 0. X squared equals 2. X is equal to plus or minus the square root of 2. So those are my critical numbers. Then it says find the open intervals on which the function is increasing or decreasing. So there we make this table up. It's 4 by 4 in this case. And when we're dealing with using the first derivative test, we use this setup where we have interval in this row. We have an x value, which is in each of these intervals. We have the sign of the first derivative at these values of x, and we can write a comment about whether it's increasing or decreasing. So we use our critical numbers to define the intervals. So we want to cover the entire domain. So we go from negative infinity to the more negative critical number, which is negative square root of 2. Then we go from that critical number to the next critical number, which is the positive square root of 2. And then we go from positive square root of 2 to infinity. So this defines the entire domain except for negative square root of 2 and positive square root of 2. And then we pick a value of x, which is in this interval. We usually pick the smallest integer that is in the interval. So here we go from negative infinity to negative the square root of 2. Well, negative 2 would be is going to be in that interval. Square root of 2 is 1.4. So, and here 0 is in this interval, and here is positive 2. Now we evaluate the first derivative, which is this equation from the other page. We evaluate the first derivative at these 3 values of x. So 3 times x squared minus 6, negative 2 squared is 4, times 3 is 12, so you get 12 minus 6, which is 6. The key thing is it's positive, so we put a positive sign there. Then we evaluate the derivative at 0, which is this value of x. So we do 3 times 0 squared minus 6, which you can see is negative 6. That's negative, put negative in there. And we calculate the derivative of positive 2, which is 3, times positive 2 squared minus 6, which is also 6, and that's positive. So put that in there, positive. So this is increasing, decreasing, increasing. Then it says apply the first derivative test to identify the relative extrema. So we look at what these comments are telling us. The comments are saying that the function is increasing in this interval. Then it gets into this interval, it's decreasing. Then we go to the next interface between the two, it's decreasing, and then it becomes increasing. So this is a maximum, this is a minimum. That's the first derivative test. So what we can say is we have a local maximum at x equals negative the square root of 2 and a local minimum at x equals the square root of 2, positive square root of 2. We're going to go ahead and plot this. I don't know if they ask us to do it or not. Use a graphing utility to confirm your results. Well, what we're going to do is we're going to plot it and then we'll confirm it with a graphing utility. So let's get a piece of graph paper. Now, one thing we do need is we need the value of the function at these two values of x. So we're going to do f of x, f of negative the square root of 2. And if we go back, find the function here, x cubed minus 6x plus 15. So we'll get f of negative the square root of 2. So we get negative the square root of 2 cubed minus 6 times the square root of 2 plus 15. So I'm going to use my calculator if I can find it. And hold on just a second. Pause for just a second. Okay, so I've gone ahead and done the calculation. So you get 20.66 for f of negative 2, and you get 19.34 for f of square root of 2. So if we add a graph, and I have to decide on the scale. So what I'm going to do is actually go to 5 here. It's negative 5 to positive 5, just because most of this is happening around 1. So if that's 5, then each mark means 1 unit here. So 1, 2, 3, 4, 5, and it's negative, and you get positive 1, 2, 3, 4, 5. And then in terms of here, 20's a maximum, so I'm going to go from 40 here to negative 40. So if we plot negative the square root of 2, which is 1.41, 20.1, it's going to be here, that's 20, so it's going to be very close to there. So it's going to be 1, 2, 3, slightly less than that, about right there. Okay, and then if we go positive square root of 2 plus 9, so that's each unit is 4, because we get 40 total for 10 marks, so it's going to be 4. So if we go 4, 4, 8, and then a little slightly higher than that, So it's going to be about right there. So that's the minimum. So if you draw this in, it's going to look something like that. Come there, and then come down to there, and then it'll go back up like that. And so you can see there's only going to be one x-intercept, which is going to be around -3. So this is so what you got is 8, 16, 24, 32, 40. So what I'm going to do is I'm going to go to the graphing program, and I'm going to input the function, which I've forgotten what it was. X cubed minus 6x plus 15. X cubed minus 6x plus 15. Graph that, and we got to zoom out. And actually, let's make it have about the same scale as what we've got here. So we want to go to the graph, and the x scale is from -5 to +5, and the y scale is from -40 to +40. We graph it, and there you go. So let me go ahead and take a picture of that. Close, minimize that. Add a page, move that over, stretch it out. So we can confirm that we got the right answer. So here's negative the square root of 2, the slightly more than 20, so that was the maximum. This is the minimum. You see we have a y-intercept here, we have one x-intercept, which is close to -3, which is what I kind of came up with. So that worked out pretty good. Okay, I already have a graph. Got the table, here's the graph, and we're done. So this next problem is going to take a little while, so we're going to create a new video for that. So we're going to stop that video.